Okay, this video is going to explain molality. It's a crazy sounding word. Quite frankly, I hate it. But molality is very similar to molarity, and if you're not careful, you'll get them mixed up. I'll put the two here together to start with. You can see the words are just one letter apart, an L versus an R. And the tops of both of the fractions are exactly the same. It's the number of moles of solute on top of both. What's very different is what they're divided by. And if you're not careful, you're going to end up using the wrong one. Molality is moles of solute over kilograms of solvent. Not solution, but solvent. And it has to be kilograms. It cannot be grams. Molarity, we've worked earlier, it was moles of solute over liters of solution. So just watch yourself. So with molality, it's kind of like molarity. I just simply plug the information into my problems. So on my first example problem here, it says, how many grams of sodium fluoride are needed to prepare a 0.400 molal NaF solution that contains 750 grams of water? So automatically I've started you out with one that works backwards, basically. I'm already given the molality. The 0.400 molal is the answer to my problem as far as this setup is concerned. Well, if it's 0.400 molal, what that tells me is that it's some number, X number of moles over the amount of water. Well, here's the amount of water, 750 grams. I need to convert that to kilograms. So I'm going to have to divide by 1,000, and that makes it 0.750 kilograms. So if I solve right this moment, I'm going to find the number of moles, which doesn't seem to help me much other than it gets me on my way. So 0.4 times 0.75 tells me that I'm going to have 0.3, it'll have 3 sig figs, 0.300 moles of sodium fluoride. Well, here's the lovely thing. I know from, I don't know, maybe 6 chapters ago, that if I have the number of moles, I can always convert that to the number of grams. I know that 1 mole of NaF is going to have a number of grams that I can find by using my periodic table. Sodium has a mass of 23 and fluorine has a mass of 19 according to the periodic table. So that means it's 42.0 grams per mole of NaF. And then 42 times 0.3 comes out to be 12.6. But I can only have, let's see. Actually, this has 3 sig figs and this has 2. I made it look like it has 3 under here, and that's my bad. That 0 was not significant over here, so it shouldn't have been significant there. So it can only have 2 sig figs. So 12.6 is going to become 13 grams of NaF. Another problem is down below. It says calculate the molality of a solution prepared by dissolving 10 grams of NaCl in 600 grams of water. So this time I need to find the molality. So molality is going to be equal to, according to this, the number of moles of solute. They don't give me that. That'd be way too easy. Instead it says 10 grams of NaCl. Well, just like before, I know how to convert that into moles. 1 mole of NaCl has a mass of 58.5 grams. I just happen to have that one memorized. So 10 divided by 58.5 comes out to be 0.1709 and then some more digits, moles of NaCl. So I'm going to store this answer in my calculator, or write every single digit of it down, and it's going to go over here as the number of moles. I just put ... on my paper to remind myself that it's actually, see, it's still sitting there in my calculator right now. It's just waiting on me to do something with it. It's going to end up divided by the number of kilograms of water. Well, 600 grams is the same thing as 0.6 kilograms. So I'm going to go ahead and take what's in my calculator and divide it by 0.6. I actually didn't need to store anything. And I will get a molality of, let's see, I need 1 sig fig. So 0.3. It's 0.28, that'll become 0.3. And our symbol for molality is kind of an italicized M. I kind of try to make it look very cursive and have a little slant to it. If you think about it, plain old little m is already taken, that's meter, and capital M is taken, that is molarity. So you got to give it some flourish in order to make it be molality. So my answer is 0.3 molal sodium chloride.